Today is Saturday the 11th of May, and if you're looking to see the CME event, one of the factors you're going to have to deal with is this moon. It's a 4-day moon, illuminates the sky. Oh, I can see a little earth shine on it. One of the factors is when the moon's out, it makes it very difficult to actually make out an aurora, especially if it isn't the right frequency of light. And this one apparently, which will be to the north later on, isn't really visible until after the moon sets. So that'll be around midnight tonight. Meanwhile, I've only got another night or two of deep sky astro that's possible. And my goal basically is to tour the Coma Virgo group, but only the Messier galaxies. And the sky is looking pretty good up there. I'm not seeing much in the way of clouds. You can see from the moon that there is no haze around it, so I should have a good night except for the moonlight. Most of the galaxies are going to be pretty close to overhead and to the east, but not as far as Arcturus. I discovered in doing a little bit of research that they all lie within about 8 degrees of the sky. And in the Coma Virgo area, and I've got some data I did some preliminary research on. Maybe I'll be able to cite some of it as we go through this tour. We're not going to get sky dark until probably 20 minutes to 10. That's another, I probably shouldn't even start now, but at least I'll track one of them down and we can watch it develop, with the idea that the furthest westernmost Messier Coma Virgo galaxies are at 12 hours and about 15 minutes in declination. They're getting pretty close to culminating probably within the next 15 minutes. So let's go ahead and see what we can turn up. Alright, it's about 9:15 right now. We got about another, I'm still seeing blue in the sky. We're having a look at Spica, and one of the things you'll notice as the sky dark progresses, we will start to lose color in the screen. Right now it's got a greenish blue cast to it. It looks a little more purple on the handycam display. I did a little research in advance of what tonight's studies, and this will probably be the last opportunity to get out with the moon advancing quickly to the east, a 4-day moon with some luminosity. We got some concerns because we're going to be covering the Coma Virgo Messier Galaxy group tonight, and they're only going to be the Messiers, although I might turn up, let's say, a 15th or a 16th magnitude galaxy just to get a sense of how deep we can go under these conditions. Okay, so the galaxies in the Coma Virgo group include Messier. It goes as low as Messier 49 and as high as Messier 100. They all lie within a range of about 45 to 60 million light years distant. The core of the galaxy is Messier 87. We'll be imaging that later on. It is the brightest galaxy and the largest galaxy in the cluster, if you accept the fact that it has extensions that go way beyond its photo or visible light components of the galaxy. The visible light only goes out to 132 million light years, which means Messier 86 is larger. However, there are extensive regions well beyond 132 million light years, going out to almost 1 million light years, or about 500,000 light years from the core that we'll be seeing later on. And those regions are populated by all kinds of material that's being drawn in because it is the most massive galaxy at the very core of the Coma Virgo group. Once again, that's Messier 87, and we'll be visiting that galaxy about halfway through our tour. Our tour begins with Messier 98. One of the things you will notice about the Messier catalog is the numeric sequence is based on order of discovery and not anything that has to do with either right ascension or declination, as it is in the JLE Dreyer compiled NGC catalog, practically all of which are entries in the NGC catalog were discovered by other astronomers, including Messier and William Herschel and others throughout the beginning in the 18th century and extending through the 19th. So here's our preliminary view. We are looking at Spica, Alpha Virgo. There will be no galaxies as far as south as Spica, however, because the most southernmost galaxy, I believe, is about 7 to 8 degrees above the celestial equator. So that would be, 8 degrees, that's Messier 49. So let us begin with our tour, and we will take some time to allow the galaxies to develop, especially given early on when we have yet to achieve sky dark. Okay, let's have this look at Messier 98. Now we haven't achieved sky dark, but 98 is pretty much just past the central meridian, so I may have to later on in the evening when it gets darker revisit Messier 98 as well as a few other galaxies in the Coma Virgo galaxy group. But I'll have to flip the scope over to the other side. So there is a bit of a view. Now I am noticing there's some pixelation on the screen. One of the things I may be doing throughout the evening is making minor adjustments to both brightness and contrast. I basically set all the parameters coming out of the Rev2 system midway, and that includes things like brightness, contrast, color and hue, etc., etc. So I put them right in the middle so I can make adjustments using the display. So let's make a slight adjustment in brightness, actually contrast. So we're going to drop contrast down to 15 and see if we lose much in the way of the view of Messier 98. Now, one of the things I've noticed with the contrast is high, you get a lot more speckling on the screen. Looking at the screen askant, I do believe we're still getting the full extent of the galaxy we saw earlier. It is about 2 fingers in width, and it's oriented from maybe the 730 position to the 130 position in terms of its presentation. Here we're looking at, once again, Messier 98. It's a galaxy in Coma Virgo, magnitude 10.1, so it's not the brightest nor is it the faintest galaxy in the group. However, it's a nice edgy supra-Egeon, 9.4 by 2.3 arc minutes, declared to be 60 million light years distant. Oh, we got a satellite passage. There we go. So the exposure time is about 3 seconds, so that thing moved by pretty quickly. Did not seem to have a smoky trail, did not make any weird right angle turns, so there's nothing unusual about that event. Okay, we're at 12 hours, 13 minutes, and 47 seconds, which is about as far west as you get in the Coma Virgo group. The Coma Virgo group is actually a part of a much more expansive group of galaxies that goes out to about 100 million light years. We're seeing the closer group, which is condensed into a region of about, like I said, 8 degrees around. And most of those galaxies range from about 40 to 60 million light years distant. And this is Messier 98, and other than being the furthest most west galaxy in the Coma Virgo Messier galaxies, it has no other distinguishing features. I will give you other distinguishing features as we progress through the evening. Not a bad view considering we're not quite at sky dark yet. Here we have Messier 99, and it is a galaxy in Coma Virgo, magnitude 9.9, so it's on the brighter side. Most of the galaxies range from about magnitude 9 to magnitude 11.5. So this is closer to one of the brighter examples of a galaxy in the Coma Virgo group. Smallish, but face on, 5.3 by 4.6 arc minutes, 60 million light years distant. At right ascension, 12 hours, 18 minutes, 49 seconds. And declination, it's a little bit further north than most. It's at 1425.01, which puts it about 6 degrees further north than our southernmost study, which will be Messier 49, that we'll get to a little bit later. Now looking at the screen, not too bad. We're seeing some spiralicity in the arms here. Bright core, expansive core region with some apparently H2 regions or star formations associated with it, especially to the 10 o'clock and the 11 o'clock position. You can see the spiral arm there and another spiral arm there. Looks like a two bright spiral arm galaxy. There's no data in here about the class of the galaxy, but I did some research. There's nothing extreme about Messier 99, but when we get to 61, I'll tell you a little bit about that. So I'm glad I did a little research in advance. That way I can move right through this and give you some verbals instead of adding captioning to this study. Notice everything is lining up pretty well with where Spica ended up on the screen. I didn't bother to center it. Now I may center up on this before we progress to our next study, which will be Messier 61. So there's our view, 9.9 magnitude, 5.3 by 4.6 arc-minute size, 60 million light years distant, Messier 99. I thought I'd let you know that I just used Messier 99 to synchronize the scope mounts, and now it's much more towards the center of the screen and slightly above where we get the best definition of image quality. Notice also the gradient across the screen is pretty decent. It's not too dark here, not too bright up there. I may adjust it later, but we're getting some pretty good views here. I think the current settings are probably going to play out for the rest of the evening, although I may explore it a little bit later. This once again is Messier 99, and we're about to move on to Messier 61. Okay, here we have forming on the screen is Messier 61, another galaxy in Virgo, Coma Virgo group, magnitude 9.6. So we're pushing the brightness up. The brightest galaxies that when I did research, and they don't always agree with the database here on the handset, is 9.3. So we're getting very close with Messier 61 to be one of the brightest galaxies in the Coma Virgo group. What distinguishes Messier 61 is it's a spiral with a bar and a lowercase bc. And if you've been following this series, you know that a bar basically is an extension of the core, so it shouldn't look roundish, it should actually look distended. Less like a star and more like a Messier 57, right, the planetary nebula with the extensions in shape. Now the lowercase bc says it's pushed off to the right in the Hubble de Vauquelaire's morphological classification scheme. Now one of the things that's very interesting about that scheme is there is a direct correspondence that I've been able to tell between the brightness, masses, and maturity of the stars. As you get further and further to the left, the stars get older and older, less massive, they become redder, but there's far more of them. Much of the nuclear material that forms a galaxy, like an elliptical galaxy, has been converted to stars, and the stars are very low mass and they're very old. Whereas in a galaxy like this, Messier 61, with a lowercase bc, is basically a B, which is 2 times removed from a lenticular class, which is when a galaxy enters into its maturity. And a C, if it's a B and a C, it's basically 2.5 times removed. You will get an A, B, C, and a D in the classifications and the morphological system. And then after that, they get to be irregular galaxies, which are in the process of formation. So Messier 61 is a fairly luminous galaxy, and it's a spiral with a bar, lowercase bc, and it, along with Messier 100, are based on these classification scheme of the least mature galaxies, large galaxies, Messier-Class galaxies, bright galaxies in the Coma Virgo cluster. Here we have Messier 100, which I believe is slightly larger than Messier-61, but it's of the same class. Spiral with a bar, and the bar is quite obvious with this galaxy. And it has a lowercase bc, so it's got pretty visible spiral arms associated with it. Almost looks like a ring. May actually be a ringed galaxy. That data is not available on the Gemini 2 handset for the Messier-Class galaxies. And Messier 100 is magnitude 9.4, so it's getting, it's right there as bright as Messier 61, perhaps a little brighter, but it's larger, 7.5 by 6.1 arc minutes. It too is listed at 60 million light years distant, but that's really rough. That's not really the kind of data you can find online if you really search for it about the distance. Once again, its main distinguishing characteristic, it's a spiral with a bar and a lowercase bc, so it's one of the less mature versions of a Messier galaxy in the Coma Virgo group. And you can see pretty well extended annular structure in terms of its spiral arms. We're still looking at Messier 100, but I want to show you that I dropped the contrast down because it looks like it's quite pixelated up there. So the brightness is still at 20, but the contrast has been dropped down to 10. I don't think, after experimenting with it earlier today with the lens cap on, that I can go much below a contrast of 10. But this is what you would, this is something you might want to compare to the previous image. Looking at the Handycam screen, it looks like we're getting a little better integration of the spiral arm components, but that could be due to the fact that we're now getting pretty close to sky dark. However, I'm going to leave it at this setting just for the rest of this, for a period of time here. I may boost it, I may not, but looking at the screen here for the Handycam, I seem to be getting a better image with a contrast level of 10, but I don't want to go much below that. Now remember, I balanced everything out, so even though the screen is saying it's a 10, it could actually be quite a bit more contrast. I could lower the contrast seriously using the Rev2's internal software parameters. But I like what I'm seeing in this galaxy on the Sony Handycam screen. What we're seeing here is Messier 84, another galaxy in the Coma Virgo group. This is in Virgo. According to the handset, it's magnitude 9.1, which is brighter than what I was able to find online for the brightest of the Coma Virgo galaxies. Galaxy is basically face-on, 6.7 by 6 arc minutes. Once again, standard value of 60 million light years distant. We're at right ascension 122503 and declination 125311, so we're about 4 degrees higher in declination than the most southern member, that's a Messier, of the Coma Virgo group. And you know what I'm going to do now? I'm going to go back to Messier 98. Hopefully we won't get any obstruction because it looks like we've entered in the sky dark. Okay, we're revisiting Messier 98, which was the westernmost galaxy in the Coma Virgo group. We looked at it before we actually got to sky dark. Now we're in sky dark. We still have a 4-day moon. It's kind of settling off to the west. It's a galaxy in Coma Berenices, magnitude 10.1, 9.4 by 2.3 arc minutes. Once again, sighted as 60 million light years distant. We're at plus almost 15 degrees, which puts it about 7 degrees further north, so it's pretty much one of the more northernmost, but not the northernmost galaxy in the Coma Virgo group. So there's our next look, and it definitely seems to have improved as the sky has darkened. Of course, after revisiting Messier 98, it's very easy to revisit Messier 99. I just have to press the next button. Another galaxy, as we mentioned earlier, in Coma Berenices, magnitude 9.9, so pushing magnitude 10, 5.3 by 4.6 arc minutes, and once again the standard 60 million light years distant. This was the second most westerly of the Messiers in the group, and this is the view we are getting now that we are into sky dark. So there you have it. I am noticing quite a bit of pixelation on the screen. I would have to check that with the lens cap on to see whether or not it's water vapor or it is an artifact of the Rev2 imager itself. Perhaps I will put the lens cap on later and we will get a chance to determine that for ourselves. Revisiting Messier 61 once again. Galaxy Virgo, magnitude 9.6, 6.5 by 5.9 arc minutes, 60 million light years distant. Its declination says it's +4, and that would be a bit further south. Let me check this here. Yeah, 61. So the data I got earlier, this would be the southernmost if indeed, yeah, it's got to be declination 4, 2820, so I'm going to have to amend my list here. Anyway, the key to this one is one of its characteristics was it's a less mature galaxy, spiral with a bar and a lowercase bc, meaning 2.5 times removed from the mature lenticular class. But here's our sky dark view, and a nice view it is. Okay, returning once again to Messier 84, which we saw earlier. What I'm going to do now is just play with the brightness setting a little bit, just to see. That's at. I'm going to go down to 15, just to see if that has any effect on how Messier 84 is seen on the screen. So we'll give it a little bit here. That residual extension there probably came from me just flexing the telescope OTA a little bit. Notice, now that I've dropped the brightness down, we're starting to get more of a gradient. Brighter here and darker there. That's usually the limit of how far I would be willing to go in terms of screen brightness. So I don't think I'm going to go below 15 this evening. And probably push it right back up to 20 because I don't think we've seen any improvement here. Okay, we'll leave it at 20. Okay, here we have Messier 85. This galaxy is in Coma Virgo, magnitude 9.1 according to the hand controller, 7.4 by 5.9 arc minutes, 60 million light years distant. So, what distinguishes this? This is probably the furthest most north in declination of the Messier components of the Coma Virgo group. It is also an example of a lenticular spiral. So, based on the various color brightnesses, distribution of light in galaxies based on star classifications and frequencies of light and deltas between the blue-violet, visible light, near infrared, further infrared, and distant infrared. Basically, lenticular galaxies typically have about a 1 magnitude difference between the blue-violet and the visual light spectrum, and that has to do primarily with stars that are a large population of stars that have a less mass than our own sun. Typically these are considered K-class stars. So K-class stars with about a mass of about half to almost the mass of the sun are the preponderant luminosity source in lenticular galaxies, whereas in ellipticals you get M-class stars, which are very red, very long-lived, very small, and very low mass, maybe a 10th to a 20th of our own sun. In younger galaxies, there we go, probably that looked like it might have been a meteor. In younger galaxies, the difference between the blue-violet and the violet is typically somewhere around 0.3 to 0.5 to 0.6 magnitudes rather than a full magnitude between the blue-violet and the visual light spectrum. So here we go with Messier 85. It is a great example of a lenticular spiral, a fully mature galaxy that has pretty much still got lots of star-forming nucleating material left in it, but star formation now is pretty solid, and I would consider it a mature galaxy heading towards aging out a little bit if it becomes an elliptical. Okay, here we have Messier 86. This galaxy is in Virgo. It says it's magnitude 8.9, which is quite a bit brighter than the brightest galaxy that I did look up today online. The brightest galaxy was 9.3. This is 8.9. I usually just use the data in the handset, but I wanted to go online to get the data to prepare for this evening's Messier Galaxy studies. This galaxy is, once again, 60 million light years distant. However, in terms of visible light extension, it's the largest galaxy in the Coma Virgo group at 155 million light years. 155,000 light years, roughly the same size as Messier 31, the Andromeda Galaxy. However, we will discover that the core galaxy of the whole system is given a value of luminous light about 20% less than Messier 86. This, of course, would be Messier 87. I'm looking at my chart here. However, it has monstrous aura of sub-visible light that goes out almost to 1 million light years, and that really makes it a far more massive galaxy than Messier 86 that we are seeing here. Well, one thing I'm noticing here is I'm getting very close to losing some aperture with the roof try on Penty Observatory. Things are drifting west pretty quickly. This is Messier 49, a galaxy in Virgo, considered to be magnitude 8.4 by this database, largish, 9.8 by 8.2 arc minutes. We're at plus 8 degrees, and originally I had thought that this was the southernmost galaxy, but we've discovered earlier that that's not the case. So what I'm going to do is push on from here. So its distinguishing characteristic before I got started was that it was the furthest most south. Oh, it is also considered the brightest at magnitude 9.3 and has the lowest average surface brightness of 13.9. So there's some other distinguishing characteristics. So effectively, Messier 49 is the brightest galaxy, and given its size, it still has one of the brightest average surface brightnesses. And as we will discover later when we find the faintest average surface brightness galaxy, that galaxy will be about a half as luminous, about almost 0.8 arc minutes fainter in average surface brightness than Messier 49. We now have arrived at the very heart of the Coma Virgo galaxy group, Messier 87. It is in Virgo. It's magnitude 8.6 according to this database, 8.7 by 6.6 arc minutes in size, once again 60 million light years distant. This galaxy is at the core and has that huge extension of non-visible light that goes out to almost 1 million light years. However, its visible light size is slightly less than M86 at 132,000 light years. It is the center of the galaxy group at a distance of 53 million light years. However, it is not the closest. The closest will be our next study, Messier 88. Okay, Messier 88's distinguishing characteristic, it is the closest of the Messiers in the Coma Virgo group to our own Milky Way, 47 million light years distant, and the center was 53, and so if we project out to the other side, basically the most distant Messier galaxies were about 60 million light years, and that pretty much played out in the data. So, Messier 88, here is our view. It looks like a suboblate galaxy presented, a tilted galaxy, fairly large in extent. And that's pretty much what we want to do here, because I've got to move on given the fact that we're going to start getting blockages of the aperture if I don't do so. Once again, Messier 88, the closest of the Messier galaxies in the Coma Virgo group. And now we're at Messier 91, a galaxy in Coma, parentheses, magnitude 10.1, 5.2 by 4.2 arc minutes, the standard 60 million light years distant attribution. We're right ascension 12, 35, 26, declination 14, 29, 45. And the main distinction for this galaxy is it is the faintest. And what is being specified here is 10.1, but when I looked it up, 91 was attributed with a magnitude 11, and that gave it, based on its size, an average surface brightness of 14.6, which is half as bright as Messier 49, the brightest average surface brightness galaxy based on the data I was able to get. I believe that data came out of Wikipedia. So there is our view of Messier 91. Here we have Messier 89, and it is distinguished as one of the two smallest Messier-Class galaxies in the Coma Virgo group. 75,000 light years in diameter, about half the largest one, which was Messier 86. However, this is an example of an elliptical class O galaxy. Basically, you are looking at a very, very large globular cluster, composed primarily of faintish red stars, class M, with a delta between the blue-violet and the violet probably approaching 1.5 to 2 magnitudes. So there's not many of those high luminosity, massive stars left in this galaxy, and the reason for that is massive stars do not last very long, but they play an instrumental role of creating the kind of radiation pressure turbulence that causes ripples in the cold dark matter, and those ripples begin the process of gravitational forces beginning to coalesce in order to create accretion disks and Bach globules. Accretion disks become stars and planets and asteroids, etc., etc. So those bright stars are pretty much gone in Messier 89. Well, virtually almost all gone, but there is some residuals left, maybe new massive stars that have formed in the past, but they don't have very long to live. Here we have Messier 90. Galaxy in Virgo, magnitude 9.5, very large, 9.9 by 4.4 arc minutes. So it's a suboblate aspect ratio galaxy. We're at plus 13 degrees and 9 minutes, 48 seconds. And right ascension 12, 36, 50. It's giving a pretty decent view of its extensions on the screen, but the one thing I don't like is I'm seeing a good deal of pixelation. Now, I have yet to suss out, I'm going to have to put a lens cap on this towards the end to test it, whether the pixelation is due to the imager or the water vapor in the night sky. But this is a pretty extensive galaxy, as you can well tell, almost 10 arc minutes across, but on this screen we're probably only seeing, let's see, about 7 to 8 arc minutes of that extent, which is pretty darn good, actually. This is Messier 58, Galaxy in Virgo, magnitude 9.7, 6 by 4.8 arc minutes. Once again, 60 million light years distant, nominal. We're at a declination 1149.04, right ascension 1237.43. In doing a data search on it, I found nothing exceptional about Messier 58 in terms of being a member of the Coma Virgo group. I don't have data on the Messier data list to tell you much about its status, but I've already determined that the most mature galaxy was Messier 89. It's an elliptical class O. The least mature were Messier 61 and 100. Those were spirals with a bar at a lowercase bc. And the example of a mature galaxy entering into the prime of its age is Messier 85, and there's nothing distinguishing about 58 in that regard due to my data lookup. Okay, we've now made the leap to Messier 59, another galaxy in Virgo, magnitude 9.6, 5.3 by 4 arc minutes, 60 million light years distant. If you're looking at it, you can see some extensions going off to the maybe the 8 o'clock and the 3 o'clock positions. Some luminosity there. I hope you've also been noticing if there's been any additional lesser galaxies in the group. I can see one off over in the distance here. So there should be quite a few fainter galaxies on the screen for presentation throughout this entire series, since there may be as many as 200 to 1,000 members of all classes of galaxies, from dwarfs all the way up to the largest, which was visible light, which was Messier 86. So some of these should have turned up on the screen during the course of this evening. Okay, here we have Messier 60. A distinguishing characteristic is that it is the easternmost of the Messier galaxies included in the Coma Virgo group. It's in Virgo, magnitude 8.8, 7.6 by 6.2 arc minutes. We're at declination 11:33:09 and right ascension 12 hours, 43 minutes, and 39 seconds. Basically, we've traveled about 8 degrees north and south from the central galaxy, which was Messier 87, and about 8 degrees east and west from that same galaxy over the course of this tour. And as I mentioned earlier, here at least is one fainter galaxy in the group. And this one is pretty much in the same field of view as Messier 60, and is probably not much more than 3 to 4 arc minutes distant. So what I'm going to do right now is I'm going to put a lens cap on the scope, and then we're going to see what we're getting in terms of pixelation, so we can determine whether or not this has to do with water vapor in the atmosphere or the imager settings itself. Here we go. Well, one of the first things you'll notice with the lens cap in place is we're getting all kinds of artifacts all over the screen. And as I understand, in terms of CCD imagers, they really should be kept cold in order to prevent these kinds of fake stars forming on the screen. The next thing you may notice is I am seeing pixelation all over the screen, and if I wanted to eliminate that pixelization, I would probably have to drop the contrast all the way down to 0. Now what we're going to do is I'm going to drop it to 0, and it's still visible there. Now remember, there's a whole bunch of settings inside the Rev2 unit itself that relates to contrast. So what we're seeing here is, even though I've dropped the contrast down to 0 on the display TFT monitor screen, we are still getting quite a bit of pixelation. So let's go back up to I believe it was 15. We'll leave it at 15. All right. So let's leave it there. Unfortunately, it looks terrible on a large flat screen when you do view this online, and that's just something we're going to have to live with until we get up some kind of a solution in the future, which might involve upgrading equipment, but that's going to take a good deal of research. And by the way, I do want to finish my NGC catalog tour before I make any changes in that regard. So I'm going to remove the lens cap now. We're going to go off and have one final view for the evening. Actually, probably two. I want to turn up at least a 15.5 magnitude galaxy to make sure that we can detect it under these circumstances. Once again, that view of Messier 60 with its neighbor. Okay, we're looking at NGC 5004A and B. 5004A is a 13.7 magnitude galaxy, 1.4 by 1.1 arc minutes, lenticular spiral with a ring 322 million light years distant. We're at right ascension 131101, declination 293811. So let's watch and see what kind of a jump we might get when, now this is probably the 13th magnitude galaxy there, because I originally aligned it up with B. So I am going to press B and see if it moves. It did not move. Okay, I'm going to go back to A. And I'm going to now say go to A. We should see that, I believe this galaxy will jump into the position of this one here, perhaps. Let's see. All right, let's watch it develop on the screen. You watch it. I am going, excuse me, I'm going to search for another galaxy to go to. Yeah, it does look like that brighter galaxy did move there, and here's our fainter member, so they kind of diagonally moved across the screen. There's a C in this picture too. It's also magnitude 15.5. Let's watch that leap as well. Didn't move. Okay, let me tell you about NGC 5004C, galaxy in Coma Virgo, magnitude 15.5, 1.4 by 0.8 arc minutes, spiral with a bar, lowercase ab, 324 million light years distant. It looks like those three galaxies, A, B, and C, may be co-located roughly in space. So there goes a little bit of an experiment there. I'm looking forward to checking it out on the screen later on. But it does look like there's a faint galaxy right about there, which means we are getting down to magnitude 15.5, despite monkeying around with settings and the fact that we have a 4-day moon. What you're seeing here is a sweet little semi-edge-on spiral galaxy. It is, in fact, NGC 5005, Galaxy in Canis Venatici. Now you would have thought that Messier would have discovered this with his scope, or his associate. This one's magnitude 9.8, 5.8 by 2.9 arc minutes, spiral with a bar, lowercase bc. It is outside the bounds of the Coma Virgo group, but it is in the supercluster group, just like our own galaxy and the local group is found. We're at 37 degrees north, so we're getting pretty close to getting some blockage of the aperture, but you can't tell it by that image. Once again, 5.8 by 2.9, so it's basically an oblately presented spiral with a bar, lowercase bc, 44 million light years distant, right ascension 131056, declination 370330, and with this very nice view, why don't we call it a carpe noctem?